So once again, thank you guys for tuning in. This is a class for business statistics for Mancosa students. So if you're doing business statistics, this is the right class. But if you're doing advanced business statistics, that's a different class. If you're doing statistical techniques in business, that's also a bit of a different class. But business statistics for Mancosa students, this is the correct class for you guys. So what we usually do is Varsity Unlimited Tutors is we offer you an introductory lecture to just introduce you to the subject that you're going to do. Within this lecture, we'll discuss the basic concepts of our business statistics, and we'll also highlight how we can further assist you as students. Now, the way that we assist students is in three ways. The first way is the tutoring lessons that we provide, which is, for example, this one that we are giving you today. So the tutoring lessons that we provide, they come at a fee of 650 Rand. The 650 Rand covers you for the whole semester for business statistics, which includes the guidelines in terms of how to answer your assignment so that you can get at least 25 out of 30 or even 30 out of 30 in your what? So we'll provide you guidelines, we'll guide you through the process of how do you do your assignment. That's number one. Then number two, we are going to go through some past exam papers in preparation for your exam so that when the exam time comes, also get a distinction in your exam. So we'll also go through exam preparation. The third thing is that we are also going to go through the whole study module. So we're going to go unit by unit from unit number 1 up to unit number 6, going through everything that the lecturer wants you guys to study. So you can come in with your questions, you go through examples, you go through the study modules, and etc. so that you are knowledgeable about business statistics. So that's the first way we assist you. Like I said, it's tutoring. It's 650 for the whole semester. That is for tutoring. Then for those that say, you know what, I don't want tutoring, I just want you guys to just assist me with my assignment or just assist me with my exam, you can come to my inbox on WhatsApp. You can just send me a message and I'll give you a call, and then we can talk further on how we assist you on a one-on-one basis. But basically, for the purposes of this video, we can assist you in that area. You can come to my inbox and talk. But for now, I just want to give an opportunity to our tutor. His name is Kuda, Mr. Svanda. He's the one who's going to be taking you through business statistics. So like I said, he's going to go through, I think it's the unit 1 that he's going to go through today and just introduce it to you guys so that you can just have a brief breakdown of what business statistics is all about. And also, you can have a test of how he delivers his lectures, because the guy is very good. He has been tutoring business statistics for a while now, and every single class that he has tutored is all very good results. I know one of the classes, almost all of the students, a distinction in that class. So yes, listen to him. If you've got questions for him, be free to ask him the questions. But if there are any other questions that you might have that have nothing to do with the lecture, you can come to my inbox. You can also maybe ask them after the lecture. Jasper will be available to answer your questions. So, Mr. Svanda, you are free now to come online and introduce yourself.
Oh, okay. Thanks, James. I don't know if I'm audible enough. Oh, okay. All right, thank you. Welcome to an introductory lecture for business statistics. Like James had highlighted, you can just call me Kuda. So I'm the one who's going to take you through this whole lecture, the whole module. So like he highlighted, this is going to be an introductory lecture just to give you an overview of how we are going to commence our lectures. So without wasting much of your time, I just made a couple of slides. Just confirm with me if you can. Just confirm if you can see also.
Yes, we can see your slides.
All right. Thank you. Thank you. Okay. All right. Perfect. Okay, so basically, I'm not so sure if you're going to cover everything in this lecture, but basically what we're going to do is we're going to cover what is statistics, types of statistics, data presentation, and hopefully maybe a little bit of calculations for you to see how we do things in business statistics. So generally, I know most of you are business people, so statistics is all around you, right? When you're talking about income, profit, turnover, forecasting, levels of production, those are numbers. It's statistics, right? So you must be in a position that you apply statistical reasoning and be able to accurately interpret results, because statistics, it's very vital when it comes to decision making, right, in a company when you are about to make some decisions. So statistics will help you to make sound decisions, right? So let's start by defining what statistics is actually, right? Statistics, basically, it's all about gathering data, right? You're gathering data. So in other words, let's say this: you want to make a decision, right? But based on as you want to make that decision, you want information that can back you up, right? So statistics will help you. The first thing that statistics will help you through is gathering the data, right? And after you gather the data, you classify, you summarize, and then you interpret and then draw conclusions from the data itself, right? So basically, this is just the steps that you take through before you can make your decision. You gather the data, you classify, you summarize, you interpret, and then you draw conclusions from the data itself. So statistics, it facilitates the informational presentation of data to support decisions. So sometimes maybe you are sitting maybe with your board and you want to make a decision. So statistics can help you to make informational presentation of the data to support whatever decision you want to make, right? So it also refers to a range of techniques and procedures for analyzing, interpreting, displaying data in order to make decisions based on the data, right? So statistics will help you to make sound decisions, right? When you want to make decisions for your company. So let's look at the types of what? Of statistics. So what I'm covering now, that's your unit 1 and unit 2, because unit 1 and unit 2 is just theory, right? It's just theory, just to give you a foundation of what statistics is all about, right? Where you use it and the types of what? Of statistics and things like that. So I'm just covering briefly unit 1 and unit 2 for now, right? Then let's talk about the types of statistics. So the first segment of statistics is what we call descriptive statistics. So the term itself, it is self-explanatory, right? It's statistics that talks about describing, right? So in other words, when you are using descriptive statistics, you are summarizing and describing data, and you summarize and describe data using what is called frequencies, percentages, measures of central tendencies, dispersion. So for now, don't worry about the terms, right? You understand them as we go on, but it's just simple things that like, for example, some of you know what is called an average, right? So an average also is part of descriptive statistics, right? Average or a mean, right? Then there's a segment called inferential statistics. So inferential statistics, it is used when you want to infer or you want to make generalization about a population, but you make that inference from a sample that you draw within that population, right? So those are the two types of statistics. In this course, we are going to look at mainly descriptive, right? Mainly we're going to look at descriptive statistics. All right, so let's talk about data presentation, because like we said, we like I had highlighted earlier on, I said statistics, you use it when you want to what? When you want to make decisions, maybe with your board, right? And then you have to present that data, right? Before you can you can make a decision, you need to present your data so that the people can see and then they understand what you're trying to say, and then you can make the decision. So there is what we call data presentation, right? So the information obtained from statistical analysis is meaningful to business managers only when it can be interpreted and communicated effectively and concisely. So if your information cannot be interpreted correctly and communicated effectively, then the people to whom you are trying to convey the message to will not understand, right? So that's the main reason why in statistics, mainly we have to pay particular attention to data presentation, right? So it is customary to convey such information through the use of summary tables and charts. So when you are conveying information in statistics, one of the most simple ways of doing it is using tables and charts. There's a reason why statisticians advocate, right, the use of tables and charts, because tables and charts, they convey information more vividly and quickly than written reports. So you come to find out that if information is in a written format and the same information is in a table or a chart, you come to find out that the table and chart conveys information more clearly, right, rather than information that is in a written format. All right. So let's look at this example, right? Where I think it's also in your study modules, if you go check. So you come to find out that these two scenarios, they're talking about the same same thing, right? It's information about some universities, right, and its rank, right, and then maybe the people that are the students that are enrolled in each and every in those universities. So you come to find that on the left side, this is the written information, right? But before I even read, I can't go on and read this information in this written format. Of course, I can read, but it would be harder for me to try to understand the information that I must take out from that written format, right? But that same information is then conveyed in a table. So basically, I can see, okay, so these are the universities, there are 4, and this one is ranked 1, and this one ranked 50, and these are the respective number of students maybe that are enrolled. But this same information is also on this paragraph, right? So you come to find out that there is a beauty behind using charts and tables when you are trying to convey information to your audience, right? So that's the point of this example, right? That instead of you trying to convey information in a paragraph in a written format, it's much more, the information is much more conveyed vividly, right, when you make use of a table or a chart. So there is another type of table that we are going to use, right, frequently, which is called a frequency table, right? Especially when the first topic that we're going to cover that does calculations, maybe measures of central tendencies, it centers around this type of table, right, which is called a frequency table. So what is a frequency table? So a frequency table, it shows the number of occurrences of a variable falling into a specific range, right, or a category. So for you to understand this definition, let's employ let's talk about this example. I want to believe, yeah, it's also in your study module, right? So the example goes like this: like, let's consider a group of 47 males of various ages, right? 12 are between 20 and 29 years of age, and 13 are between 30 and 39 years of age. then 7 are between 40 to 49, 8 between 50 to 59, while the rest are between 60 to 69 years, right? So this is information that we are being given, but we are given in written format, right? It's too much for us to grasp, right, to handle. So what the beauty of a frequency table now is you can actually, right, group. Okay, so when you employ what is called a frequency table, what you are doing basically is you are grouping your data, right? That's the main purpose of using a frequency table. You are just trying to group the data. Like in this instance, we create a frequency table, right? So it has 2 rows, where one is the intervals, the number, the years, and then the number of males. So what this table does is it is showing the number of occurrences of a variable, right, falling into a specific range or category. So what I'm trying to say is, here we can see that the interval of the years is what? Is 20 to 29. So how many people out of 47 males do we have that what? The age that lies within this category. So you come to find out that there are 12 males whose ages are between 20 to 29, right? Then you come to find out that there are 13 males whose age lie between 30 to 39, 7 whose ages lie between 40 to 49, and so on. So what you are doing basically is you are grouping people that have the same interval of years together, right? People that have got ages between 20 to 29, you are grouping them together, and then you count, and then you come up with a figure which is 12. So that's where the issue of group is coming into play. You are grouping people based on a specific range or a specific category. In this case, we are saying the number of years is what is grouping the people the people together. So from this information, we can take note of the following, right? That the majority of the males are young. So how did we see that the majority of the males are young? Because you can see that, let's just say maybe let's say anyone who's below maybe 39 is young, right? So you can see that if we add this is 25. So which is true, right? The majority of the males is what is it lies below what 40 years, right? Which is correct. But this kind of information, it's very hard for you to deduce if it is in the written format, right? Then also you can see that most males lie between 30 to 39, which is correct, because this is the category that has the highest frequency, right? The highest number of occurrences of that variable, right? Then also here you can sum all the number of the males, right? If you add everything here, you must get 47. Right. So that's the purpose of a frequency table. When you are employing what is called a frequency table, you are trying to group the data. Don't worry, later on I'm going to explain between the 2 types of data, right? We have what is called ungrouped data, and we have what is called grouped data. So when we are dealing with grouped data, you can't talk about grouped data without talking what is called without mentioning what is called a frequency table, because a frequency table is what you use to group the data, right? So let's look at another example that is also in your study module. So consider a class consisting of 100 students. Suppose the teacher gives the entire class a statistics test, which has a maximum mark of 100. Upon marking the scripts, which are in no order whatsoever, he puts the marks into a table as shown below. This represents raw data since there is no set order of marks. All right, so let me try to explain this last statement, right? When they are saying this represents raw data, so when you are gathering information before you process it, when you gather information from, okay, let's take this example, right? So when the marker right, or the lecturer or the teacher in this case, right, when he gets the scripts, right, before he groups the scripts, that type of data is called raw data. He hasn't processed it yet. He just gathers the data, right, and put it in one place, right? So before he does anything, that type of data is called raw data because he hasn't set it in any particular order, right? So that is what is also referred to as ungrouped data, right? Raw data is also considered to as ungrouped data. So these are the marks, right? So these are 100 students. So you can see from the data, if you check, right, you come to find that the maximum value is the maximum mark, right? It was 90 and the minimum was what was 80. So there is what they call a range, right? We are subtracting the maximum value from the minimum value within that the data that you have been given, right? So the range there is what is 82. So I'm going to show you later on, but not today, but later on to those that are going to impact with us on this course. So I'll show you how you are going to do, how you come up, right, with a what, with what is called a frequency table, because you know business statistics module requires you also to be able to make what is called a frequency table. So I'm going to show you how you do that, right? Given raw data, there are some certain steps that you must do and take so that you can come up with a table like this, right? A frequency table. So now, why is it now that there is what they call a cumulative frequency table? A cumulative frequency, right? So I'm going to explain this other column that has been added, because on the last example, we only talked about the interval and about the frequency, which is the number of occurrences of a variable, right, within that specific range. But now I will explain in a moment what cumulative frequency is. But before I go any further, I want to explain that this column that is an interval here, right? Let me try to take a pen here. So you come to find out that each interval, right, it has two figures, right? It has one that is on the left, which is the minimum value for that specific interval, right? And then there's a value on the right, which is the maximum value, right, for that specific interval. So there are three terms that I want you to take note of, right? There's what they call a lower class limit. Then there's what they call an upper class limit. Then there's what they call a class width, right? So what is called a lower class limit? Lower class limit is the lowest value for that specific interval. Like in that case, from 0 to 9, right? The lower class limit for this class is 0, and the upper class limit is what? Is 9. For the next interval, the lower class limit is what? Is 10, and then the upper class limit is what? Is 19, right? So for each and every interval, there must be an upper class limit and a lower class limit. And the rules of statistics when it comes to creating a frequency table, these limits must not overlap, right? As you come to see, we are starting from 0 to 9, but the next interval is not starting from 9. It's starting from 10. That is another rule that you must also take note of when you are creating what is called a frequency table, right? Then the other thing also is what is called a class width, right? So you can easily calculate the class width because you want to see like what is the width between 0 to 9. So one might say, from 0 to 9 it's easy, it's 9, right? Which is wrong, right? Which is wrong, because if you count from 0 to 9, you come to find out that it is 10, right? So if you start counting, like if you put your fingers together, right? If you start to count the first finger as 0, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You come to find out up to 9, right? You come to find out that the 10th finger, right? It will be number 9. But how do you calculate now that class width using the data without counting on your fingers, because sometimes the interval might be so big that you can't count on your fingers, right? So the easiest way for you to do is, there are two ways that you can calculate what is called the class width, right? So the first way, you can use lower class limits only, right? Where you say lower class limit for one interval, right? Which is this one, subtract the lower class limit of another class, right? But it must be preceding, right? It must be the classes that they are adjacent to, right? So in this case, let's take these two class limits, right? So you say 10 minus 0, you get what? You get 10. So 10 is the class limit, right? Let's take another class here. Let's take 80 and 70, right? So 80 minus 70, right? You come to find out you still get what? You still get 10. So that's the first way for you to determine the class width, right? You subtract the lower class limits of two adjacent classes, right? Or you can also use what is called the upper class limits, the two adjacent upper class limits, right? In this case, we can take 19 and 9, right? And then we say 19 minus 9, you still get 10, right? Even if we take 89 and 70, if we subtract, you still get 10. So as long as the classes are adjacent, as long as you are subtracting lower class limits or upper class limits, you don't have to mix. If you say upper class limit minus the lower class limit of the adjacent class, you have a wrong answer, right? So if you are using lower class limits, stick to lower class limits, right? If you choose to use upper class limits, then stick to the upper class limits. So I want to believe that this is clear, right? Then now the frequency, this is the number of occurrences, right? So it means that one person got a mark that was between 0 to 9, and then two students they got marks that lied within 10 to 19 and so forth, right? So now let's come to this column that is called the cumulative frequency. So cumulative frequency, now we are saying, right? We are saying that since the first frequency was 1, right? So that would be the first cumulative frequency. Now, to write the cumulative frequency of the second class, we are saying the cumulative frequency of the previous class plus the frequency, right? Plus the frequency of that class that you want to calculate the cumulative frequency for, right? So this is 2 plus 1, you get what? You get 3. So for us to get this cumulative frequency of this class, what you do is you say cumulative frequency of the previous class, which is 3 plus what? Plus 5. 3 plus 5, you get 8, right? And then the same thing again, cumulative frequency for this class, which is 14, right? You say cumulative frequency of the previous class, which is 8, plus the frequency of that class, which is 6, and so on, up until you get to 100, because there are 100 students that wrote the exam, right? So the last number of the cumulative frequency must be the same as the total number of your sample size, right? Because you are just adding those frequencies together, because remember, the frequencies are just representing, in this case, the students, right, that wrote the exam, and they've been grouped according to the mark that they have. So that's a way of grouping these students together, right? You are grouping them based on the mark that they got. When you finally add that total number of frequencies, it must give you 100, right? So basically that's the logic behind the cumulative frequency, right? All right. So we said that when you remember, we're talking about data presentation, right? We are talking about the ways that you can convey information to your audience. So the first type of data presentation method is using what? A table, specifically a frequency table, right? Now there are other 2 ways that you can use right, to convey your information to your audience, right? So though a table sometimes can be useful to present detailed data, but a picture and a diagram can be more powerful when you want to focus your attention at a specific trend or a dominant feature, right? So though a table to a certain extent, it can convey information vividly, but it is limited now, right? Especially when you want to check whether maybe you want to check, maybe you are calculating a profit or you want to calculate the loss, right? You can't find the trend, right, from a table, right? So that's where the table is now limited. When you want to check, right, whether if maybe your data is following a normal distribution curve, you can't check that from a table. You need another type of data presentation method that you can employ, right, for you to see, right, that dominant feature or that trend. So that's where graphs come into play. Graphs and charts, right? So the most important graphs that you're going to talk about, we're going to talk about in this lecture is the line graph, bar graph, and what? And the pie chart or the pie graph. So let's look at each and every graph. And let me just try to explain a little bit about it, right? So let's look at this example. It's also in your study guide, right? So this is a company, right, that has been operating maybe for a while, and then there's data that was collected for 97, 98, 99 up to 2002. So these are the profits, right, that they got. But now these guys, they want to know whether they were making a loss or whether they were making a profit. From the data on the left, they can't see whether there is a trend that they are following, right? They can't see. So the best way here is to instead of using a table, is just to make what is called a line graph, right? Where this here is put on the horizontal axis, right? And then the profit itself is put on the vertical axis, and then you plot this data, because remember, this one is 78, so 78 is here, right? This 65. So when you join them, the reason why it's called a line graph is because the points themselves, they are connected using a line, right? So that's why you can see it's a line here, right? So a study of the table shows that the profits have dropped considerably. This trend can be better depicted using a line graph. So that's the beauty of using a line graph when you want to see the trend. So you can actually see the trend here perfectly as compared to as compared to the information that is on the left, right? So each and every method of data presentation, it has its own advantages and its own limitations. So this one, when it comes to a better depiction of a trend, tables, they are not good in conveying such information. Another type of chart that you also find in this course is what is called a bar chart, right? So a bar chart, basically, it consists of series of bars, right? And the length of each bar representing the value of the variable being plotted, like in this case, right? This is the profit, right? And then this is the year. So this the length of what? The length of the bar, right? It represents the value of that particular variable. Now, the good thing about your course, right? The good thing about your course is that you are not going to draw these graphs manually, right? You're not going to draw this graph manually. You're going to you use Excel, right? So I'm going to show you later on, as we go deep into the calculations, how you are going to be using Excel to plot, some graphs, right, and some bar charts, and also how to use Excel, right, when it comes to creating the cumulative frequency table, right? So I'm going to show you those things later on. All right, so pie chart, right? There's another type of presentation or method of presenting data, which is called a pie chart. But now this chart, it is used to depict a certain type of information, right? So you use it when usually you want to depict proportions, right? Proportions of a certain value as compared to the whole value, right? Like in this case, let's look at this example that it's also inside the module, right? Where a father gives, right, his 3 sons money to spend, right? And then the eldest gets 120, right? Then the second one gets 80, and then the youngest get what? They get 50, right? So now pie chart now can allow us to see how much money Josh got compared to what? To the total amount that the father gave all 3 of them, right? Like in this case, when we add all these 3 values, we get 250, right? So to find the percentage of Josh, right, as a fraction of the whole amount, right? What you do is you say 120 over 250, right? And then you get 48%. This is this gray part there, right? And then mat is 80 over 250. That gives you 32%, which is this yellow part, right? And then David got 50 out of 250, right? Which is what? Which is 20, which is this brown part. So basically now you can actually see clearly, right? That, okay, so this is the fraction, right? This is the proportion, right? Of the amount of money that Josh got as compared to the whole amount, right? So that's where you use pie charts. Then there's what we call histograms, right? So a histogram, it looks like a bar chart, but it is not a bar chart, right? It's a special type of a bar chart. Let me just say something like that, right? It's a special type of a bar chart. So this type of graph, right? It is used to display a frequency distribution data. You remember we have what is called a frequency table. So when you want to draw a bar chart of the frequencies, it's no longer called a bar chart. It's now called a histogram, right? So a histogram, it is a display of the frequency distribution, right? So as long as you want to depict a frequency from a frequency table in form of bars, then it is called what? It is called a histogram. All right. So guys, before I just delve into this, I know I'm now left with just a few minutes, but just before I can give you another foretaste of this lecture, if there's someone maybe who has a question, you just feel free maybe just to raise your hand, right? Because one thing that I also want to tell you is these lectures are interactive. There are times where, you know, I want to hear some of you, maybe if you are not understanding something, right? Just feel free to just ask, so that I can try by all means to clarify whatever point you'll be bringing across. Because when I'm just saying this, when the people are not asking questions, so I will be assuming that we are on the same page, right? So just feel free, if you're not understanding a certain concept that I just laid out, just raise up your hand, or you can just type in on the chat, right? Even if for the future lectures, right? That is how we go about our lectures. So just feel free. All right. So basically, up until this point, that is unit 1 and unit 2, right? Because basically it's just theory. That's why, you know, I didn't try to spend much time on unit 1 and unit 2, because even if when it comes to writing your assignments and your exam, they don't contribute that much, right? if it's an exam, there might be one question or two questions, or there might not be any questions at all, or regarding what? Regarding unit 1 and unit 2. So it's just background, right? It's just foundation for you to understand the statistical methods that you will be using later on. Like, for example, now that we are about to talk about what is called the measures of central tendencies, we are going to be mainly dealing with the frequency table, right? So for you now to understand how to calculate some of the things without you understanding what the cumulative frequency table is, then it will be a hard thing for you to grasp, right? So let me okay. So let me define what a measure of central tendency is, right? So a measure of central tendency, it is a single value, right, that attempts to describe a set of data by identifying the central position within that set of data. So you have a group of data, right? Let me not just say a group of data per se. You have got data that you have gathered, right? And then you want that data to be described in using one value, right? Based on the position that you would have calculated from that set of data. So basically that's what central tendency is, right? So it measures, these measures of central tendency, they help you to find the middle, right, of your data, the middle position of your data. They also allow you to calculate what is called the average or the mean of your data, right? So basically there are three, right, numerical measures of central tendencies, right, which is what we call the mean, which is the average. Then there's what they call the median, which is mainly about the middle part of the data, right, and the mode. So mean, median, and mode, they are considered to be measures of central tendencies, because you are calculating in each of all these instances, right? You are calculating a single value, right? In this case, right, you are calculating a single value that will be an average of what? Of the whole data. In this case, you're calculating a single value, which will be the middle part, the middle position of your of your data. So basically, that's what measures of central tendencies are. So before we go deeper, right, we need to understand the two types of data. Like I had said, I was going to explain later on the two different types of data, right? So I want your undivided attention on this, because this whole unit is based on this slide. Once you miss this slide, right, it will be very hard for you to tackle, because the questions that your lecturers will ask you, right, for you to calculate the measures of central tendencies is based on the knowledge that I'm supposed to convey now, right? So just make sure that you really get this before I continue. If you still have any question, please raise your hand before I continue, right? Because I want to make sure that we are on the same page. So what you need to understand now is data is divided into two, right? There's what we call ungrouped data, which is raw data, and there's what we call grouped data. Now, the reason why they are grouping this data, because they are the method that you use to calculate the median, the mode, and the mean for ungrouped data is different from the way you calculate the mean, mode, and the median for grouped data, right? I hope you're getting me. The methods that you're going to use to calculate, right, the measures of central tendencies for grouped data is different from the methods that you're going to use, the formulas that you're going to use to calculate the measures of central tendencies for ungrouped data. So that's the reason why I wanted you to understand the difference between the two. So what is ungrouped data? So data that you first gather from an experiment or study is what? is considered to as ungrouped data, right? So, like for example, when that teacher, when he was just gathering the scripts together, right, that was ungrouped data, gathering the information from the study, from the experiment. It's termed ungrouped, right? So the data is raw, it's not sorted, right? So ungrouped data is usually given as individual data points, like that table that they had for each and every student, right? The mark that was for each and every student, right? But now grouped data, you are grouping data given in intervals. That's where you start to use the frequency table now. So you are using the frequency table to group data into specific ranges, into specific categories. So you are grouping people based on the mark that they get, the range of the mark that they get. Those that got a mark from 20 to 29, you're grouping them together, right? Those that got marks from 40 to 49, you are grouping them together. So you are grouping them based on a certain interval that you as a statistician has come up with, right? Then the data is going to be bundled together in categories, and then now you depict the data now either in histogram. Remember, histogram is a bar chart that is created from frequency distribution, right? A histogram and then a frequency table. So the same information, whether you choose to use a histogram or a frequency table, it's still the same because it's the same information. All right. So I think I'm just going to show you just maybe this mean before I give James back the time, right? Maybe just a mean, and then I'll see if time will permit me just to show you the median, and then for today it will be what? It will be done, right? So let's look at this slide. So this slide is saying mean, mode, median for ungrouped data. So like I said, the formulas that you use for mean, mode, and median for ungrouped data is different. Let me just show you. Maybe let me just go. You see, now we are. You can see that the formula, right? The formula for a mean for grouped data, right, is this one. But if you check the formula again for ungrouped data is this one. So they are different, right? So that's why I was saying you need to really, really grasp this concept, right? Before we can delve deeper into the calculations. Because the moment you fail to understand the differences between ungrouped and grouped, then it means the possibility of you misinterpreting a question is very high. Because sometimes your lecturer can give you raw data and then they say calculate the mode, right? Or calculate the mean. So if you can't tell whether the data you have been given is grouped or ungrouped, it means that you have failed already. You must be able to identify the type of data that your lecturer will give you. Did they give you raw data? Did they give you grouped data? So if they've given you grouped data, use formulas for grouped data. If they've given you ungrouped data, then use the formulas for ungrouped data, right? So this is the mean now. How to calculate the mean for ungrouped data. So what you do is you find the sum of all observations, then divided by the number of observations, right? So let's look at this illustration. So there are some 7 learners, right, that wrote a spelling test, and these are the marks that they got. Now for us to calculate the mean, we're going to add each and every mark that each and every student got, right, which is this upper part, divided by the number of students that wrote the mark, the test, which is what? Which is 7. So if you add all the marks by the number of the students that got the what? That wrote that test, you come to find out that the average mark was what? Was 66.86. So this value is describing, right, the performance of the students. Basically, roughly, we are saying roughly each student got around 66.86. So that's what we are just saying. We are saying roughly this figure is a rough estimate of what each and every student got, right? So that's the purpose of what? Of the mean, right? Now let's look at the median, right? this one, it talks about the position, the middle point, the middle position of what? Of the data, right? So the median is the middle number of an ordered set of data. So the keyword here is ordered, right? It's ordered, is not grouped. When you're saying ordered, we're not saying we're grouping it, but we are just writing the values in a particular order. We are writing the values in a certain order. So the keyword is the median, is the middle number after you order your data. So if you find the middle number without ordering your data, then it's not a median, right? You first have to order your data first, right? You put your data in a certain order first, and then you find the value. So the order is ascending order, right? You start with the smallest value to the biggest value, right? So after you arrange your data value, right, in ascending order, right, you then do the median. Now that value is what divides the ordered set of data into two equal halves, right? So after you set your data in ascending order, the value that you calculate as the median is that value that divide your data into two equal halves. So data above, right? Data above that value will be half, right? And data below that value will also be half, right? That's what the median is all about, right? Now, one thing that you also must understand for ungrouped data, right? The formula that you use for odd, if your data set, right, is odd number, like maybe you've got 7 students, number 7 is an odd number, right? Or if it is an even number, right, it's a number that is divisible by 2, right? Like maybe instance 8, right? So if your data set is an odd value, you use this formula to calculate the median position, right? But if the number of data sets, right, is even, then it means you have to use what? You have to use this formula there. So those are the other things that you must pay particular attention to. The number of the number of the data set, right? Is it odd, or is it what? Or is it even, right? So that you are able to clarify, right, to the type of formula that you are using. So let me use this example, right? So find the median number of cars sold per month by a dealer over the past 9 months based on the following monthly sales figures, right? So they were taking the monthly car sales for 9 months. So the total number of observations was what? Was 9. So in 9, we can clearly see that it is an odd number, right? So the first thing that you need to do, we need to set this data into an ascending order, right? So we start with the smallest value, which is 12, and then we order it up until we get to the maximum value, right? So from the previous slide, we can see that the median value, right, it will be n plus 1. N in this case is what? It's 9, right? So it has to be 9 plus 1 divided by 2, right? So 9 plus 1 is 10. Then 10 divided by 2, it's 5. So the 5th position, after, right, you have managed to set your data in ascending order. The value on the 5th position is your median. So you count 1, 2, 3, 4, 5. So now the 5th position, which is this one, this is your median. So what does it mean? It means that this data has been divided into 2 equal halves. Is it true? Let's check. 1, 2, 3, 4. So we have got 4 values above, right? Above what? Above the median value, right? Let's count how many values are below the median value, which is 1, 2, 3, 4, which is correct, right? So the median position, it divides your data into 2 equal halves. So the median value here is what? Is 34, right? So this means that there were 4 months when car sales were below 34 cars per month, and 4 months when car sales were above 34 cars per month, right? So basically that's how you interpret your data using the median. For the mean, we just said roughly each student got 66.86, right? Now, when you are dealing with the median, you are saying there are 4 months where the car sales were below 34 cars per month, right? And then there are 4 months when the car sales were above 34 cars per month. So let's look at instance where the number of observations is 10. In this case, it's not 9, right? So it's now 10. So what we do, the same thing again, we order the data into what? Into ascending and descending order, right? And then now what you need to do is you say, since n, right, is equals to 10, right? You just say 10 divided by 2, which is the 5th position. So you have to identify the 5th position, right? 1, 2, 3, 4, 5. So the 5th position is this one, right? But what you do now is, after identifying that position, you take the value which is next to it, right? Which is the 6th position, right? The value on the 6th position. So you add 27 and 34, right? And then you divide by 2, right? What you get here is 30.5. So your 30.5, right? Which is the value that will be here, right? So let's check if 30.5 is the value that divides, right, the set of data into 2 equal halves, right? So you see that there are 1, 2, 3, 4, 5, right, months, right, that are before what, the 5 values that are above the median, and 5 values that are below the median. So which also means that there were 5 months when car sales were below 30.5 cars per month, and 5 months when car sales were above 30.5 cars per month. So basically that's how you calculate the median. Then, just to close this lecture, the mode now, that's the most frequent occurring score, right? The number that repeats the most in your data set, right? Like in this case, you can see that 64, it is repeated twice, right? So it means that the mode for this data is what? Is 64. So the number, the values that are repeated the most number of times, that is your mod. All right. So guys, thank you very much for your time and your attention. I hope this lecture was informative. I just tried my best to deliver some of the information as an introductory lecture, so that you can have an idea of the type of lectures that we are going to have and how I also deliver that type of content to you. So let me end this opportunity back to James, so that he can say 1 or 2 things, unless maybe there's someone who has a question.
Okay. Thank you very much, Mr. Sibanda, for a wonderful lesson delivered. I also became a statistician today. And a warm welcome to all the people that joined us today. The voice that you are hearing, the voice of Jasper. Most of you have taught you management accounting. I can see the names there. I can see Tieho, Lindle, I can see Charlene, Halaletsang, I still remember, Paul. All right, guys. So going forward, all the information will be communicated to you in the group. So for today and going on, Mr. Sibanda is going to be your lecturer. Thank you so much. Enjoy the rest of your evening. Thank you, Prof. Sibanda. That was superb.
Thank you, sir. That's fine.
All right. Thank you so much.
Thank you.
Thank you so much.
Thank you.